So the ordered pair or the point is in the form x, y. So this is the abscissa, the x, and the y coordinate is called as the ordinate. Now if we're going to plot a point, what we're going to look at first is the abscissa. So for the abscissa, if this one is negative, then you're going to move starting from 0 towards left, towards the negative side. So this is towards left. Now if x is positive, then from 0 you're going to move towards right. Okay, so this is the x is for the x-axis. Now if we're going to have y, if the value of y is negative, then you're going to move down. So you're going to move downward. And if y is positive, then you're going to move up. So if y is positive, you're going to move up, then negative, move down. Then if we're going to have x, you're going to move towards left if x is negative. Then you're going to move right if x is positive. For example, if we're going to plot these points, number 1, let's have 6, 4. Number 2, point negative 5, 3. Then number 3, point negative 2, negative 4. Then 4, let's have 3, negative 10. Then 5, let's have 0, 5. 6, 0, negative 4. Then 7, let's have negative 5, 0. And 8, let's have 3, 0. So let's have number 1. Number 1 is 6, 4. So the starting point is the point of origin. This one in here. So this is the starting point. So x here is 6. So x is positive, so you're going to move towards right. So this is 6, so we're going to move 6 units. So 1, 2, 3, 4, 5, 6. Then y is 4. This is positive, so you're going to move upward. So in here, from 6, you're going to move 4 units up. 1, 2, 3, 4. So this is now point 6, 4. For number 2, point negative 5, 3. So starting point in here, 0. X is negative 5. So what you're going to do is you're going to move towards left. 1, 2, 3, 4, 5. Then y is 3. So positive. So you're going to move up 3 units. 1, 2, 3. So this is point negative 5, 3. And number 3, this is negative 2, negative 4. So starting point, x is negative 2, so move to the left. 1, 2. Then y is negative 4, so you're going to move downwards 4 units. 1, 2, 3, 4. So this is point negative 2, negative 4. Then for number 4, this is 3, negative 10, x is positive, so we're going to move starting from 0, 3 units. Move towards right. 1, 2, 3. Then y is negative 10, so you're going to move downward 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in here. So this is 3, negative 10. Then for number 5, this is 0, 5. So x here is 0, so you will not move. So starting here, x is 0, so do not move. Then y is 5, so this is positive, so we're going to move upward. 1, 2, 3, 4, 5. So this is 0.05. The number 6 is 0, negative 4. Again, x is 0, so you're not going to move. Then y is negative 4, so you're going to move 4 units downward. So 1, 2, 3, 4. So this is 0, negative 4. Number 7, negative 5, 0. X is negative, so you're going to move towards left. 1, 2, 3, 4, 5. Y is 0, so you're not going to move upward, neither downward. So you're going to have this point. So this is negative 5, 0. Then the last number, number 8, 3, 0. X is 3, so positive, so you're going to move 3 units towards right. 1, 2, 3. Then y is 0, so you will not move upward or downward. So this will be the point. So this is 0.30. So rectangular coordinate system is also called as the Partition Plane. This is in honor of the French mathematician René Descartes, or others will read this one as René Descartes, who is known as the father of modern mathematics. So this is now the Partition Plane. So I'll just use here a graphing paper. So if we're going to illustrate or describe what is a Partition Plane, this is just two perpendicular lines. So this vertical line here, this is called as the y-axis. And the horizontal line here, this is the x-axis. Then these two perpendicular lines meet at this point. This point here is called as the origin. And the origin, the coordinates of this one is 0.00. So the center here, this is 0. Then the upper numbers here for the y-axis will be 1. Then this is 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is infinite up to positive infinity. Then below will be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, up to negative infinity. Then on the right here of the x-axis are positive numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to positive infinity. On the left, it's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, up to negative infinity. Then, these two perpendicular lines here divides the plane into 4 quadrants. So, this quadrant here will be quadrant number 1. Then quadrant number 2. Then this is quadrant number 3. And this will be quadrant number 4. Now, partition plane is composed of infinitely many points. So, there are many points or infinite number of points found in this plane. Now, each point in the coordinate system is defined by an ordered pair. So point is an ordered pair, and the form for this one is x, y. Then the first coordinate here, the x, this is called as the x coordinate or the abscissa. And y here, the second coordinate, this is called as the y coordinate, or this is also called as ordinate. Now going back to the quadrants, so for quadrant 1, all of the points here has a positive x and positive y. So this is a sign of the coordinates. So for abscissa, it should be positive, and for the ordinate, it should be positive. If we're going to have quadrant number 2, the abscissa here will be negative and the ordinate will be positive. Then for quadrant number 3, the abscissa here is negative, so as the ordinate. And for quadrant number 4, the abscissa here is positive and the ordinate is negative. And there are also points found on the x-axis and the y-axis. So the points that lie on the x-axis has the coordinates x0, and the points that lie on the y-axis has the coordinates 0, y. So these are the points found on the axis. A line can be described by its steepness or slope. So the slope m of a line can be computed by finding the quotient of the rise and the run, or in this formula we have the slope m equals rise over run, or this is equal to the vertical change over the horizontal change. If 2 points of a line are given, we can determine the slope m using the formula below. So this is the formula in finding the slope of a line. So m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, or another formula is m equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2, where x sub 1 is not equal to x sub 2, because if these two are equal, then it means that the given is undefined. So we have here examples of finding the slope given 2 points of the line. So we have here number 1. The line passes through the points 2, 3, and 1, 4. So we're going to find the slope. So in here, in finding the slope, we're going to use the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And in here, we're going to determine first what is x sub 1, y sub 1, and what is x sub 2, y sub 2. So we can have the point 2, 3 here as x sub 1, y sub 1, and 1, 4 as x sub 2, y sub 2. And after assigning the values of x sub 1, y sub 1, x sub 2, y sub 2, we are going to substitute this one to the formula. So we're going to have here m equals y sub 2 here is 4, then minus y sub 1, which is 3, divided by x sub 2, 1, minus x sub 1, 2. So 4 minus 3, that will be 1. Then 1 minus 2 is negative 1. Then 1 divided by negative 1, that will be negative 1. So the slope of this line here that passes through these points is negative 1. Then number 2, the line passes through points negative 5, 6, and 3, negative 4. So we're going to find the slope. So first, determine x sub 1. This is x sub 1, y sub 1. Then this will be x sub 2, y sub 2. Then, using the formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, we can have y sub 2 is negative 4 minus y sub 1, 6, divided by x sub 2, 3, minus x sub 1, which is negative 5, so we're going to have here negative 5. Then, m here will be equal to negative 4 minus 6, that will be negative 10, divided by 3 minus negative 5, that will be equal to 3 plus 5, that will be 8. Then simplifying this one, negative 10 over 8 is divisible by 2. So we can have negative 10 divided by 2, it is negative 5. And 8 divided by 2, that will be 4. So your slope here is negative 5 over 4. So this is the procedure in finding the slope of a line given 2 points. So the slope of the horizontal line is 0. So if you have computed that the slope is 0, then it means that that line is horizontal. Then the vertical line is undefined, meaning if your computation of the slope is undefined, meaning that line is a vertical line. Then a vertical line does not represent a linear function. So we have here the trend of the graph of a line using the value of the slope. Number 1, if m is positive, then the graph is increasing from left to right. So from left, it will be increasing to right. So this will be the form of the graph, or this will be the graph of a line that where m is positive. Then if m is negative, then the graph is decreasing from left to right. So the graph here will look like this. So from left to right, it will be decreasing. Then if m is 0, then the graph is a horizontal line. So simply a horizontal line. Then if m is undefined, then the graph is a vertical line. So the graph here will be a vertical line. In the slope-intercept form, y equals mx plus b, m here is the slope. So if you will be given a linear equation using this format, you can determine the slope using the value of m. So for example, if you are going to have y equals 2x minus 4, then your slope here will be 2. Another example, if we're going to have y equals negative 1/4 x plus 3, so the slope here is equal to negative 1/4. And in here, you can also determine the trend of the given linear equation. So for example, this one is 2. The slope is 2, meaning the trend here is increasing from left to right. And this one is negative, therefore the trend here will be decreasing from left to right.